Okay, so think about a huge website Netflix, Amazon, whatever you like. You open it from London, from Mumbai, from anywhere, and it feels instant everywhere, right? Now, here is the puzzle their servers are not sitting next to you, they might be on the literal other side of the planet. And there is one hard limit that nobody with any amount of money can get around the speed of light. It is the exact floor we ran into back in the latency video. Let's say the server is in Sydney and you are in London. That is about 17,000 kilometers apart. Now, light inside a fiber optic cable travels at roughly 2 lakh kilometers per second. Incredibly fast, but not infinite. So, even at full speed, your request takes about 85 milliseconds to get there and 85 to come back. That is about 170 milliseconds round trip before the server has done a single thing. And a web page is not one request, it is dozens of little files, each one able to pay the same tax. The problem was never a slow server, it is a far server. And you cannot make light go faster. So the trick is the exact opposite. If you cannot make the data move faster, you make it start closer. That, in one line, is the whole idea of a CDN. Let us build it up. So, at high level, a CDN, which stands for Content Delivery Network, is just a big set of servers spread all over the world, sitting physically close to where users actually are. Each of those nearby servers is called an edge server, and the locations they live in, near big cities, are called points of presence or POPs. And the idea could not be simpler. Instead of your request flying all the way to Sydney, there is a copy of the content waiting in a box right near you, maybe 5 milliseconds away instead of 85. And that original faraway server, the one true home where your content actually lives, that gets a name too. We call it the origin. The origin still holds everything. The edges just keep copies close to people. And here is where it all connects. If you have watched the last video, what is that edge box really? It is a reverse proxy, that exact middleman we met, the one that sits in front of your servers and can cache responses. A CDN is just that same reverse proxy cache, copied out to hundreds of locations around the world. Same idea, new address. Okay, so how does a copy actually get to the edge near you? Think about it. The edge's shelf starts completely empty. So, where does that first copy even come from? Watch the very first person. Someone in London asks for, say, the site's logo image. The London Edge checks its own shelf. Do I have this? And the first time, it does not. That is called a cache miss. So the Edge goes all the way home to the origin. Just this once, grabs the logo, keeps a copy on its shelf, and hands it back to you. But now, the next person in London asks for the same logo. The Edge checks its shelf again, and this time, yes, it's right there. That is a cache hit. It serves the copy instantly, from a few milliseconds away, and it does not bother the origin at all. So the first visitor pays for the long trip home. Everyone after them rides free. And notice this quietly does two good things at once. One, it is fast for users because the copy is right next to them. Two, it protects the origin as well because once the shelves are warm, most requests stop at the edge and never travel home. So when a million people show up at the same moment, your one origin server barely even feels it. The edges soak it all up. The cache is a speed up and a shield at the same time. Now, I keep saying the edge checks, do I have this? But what is this exactly? And this is the one idea that makes everything else in caching click. Right. So, the edge does not just look at the path like slash logo. It builds something called a cache key. Simply, its own notion of the same request. Usually, that key is just the path, but it can also fold in things like the query string or certain headers. So take two files app.a3f8b2.js and app.9c2f1e.js, different names, so different paths, which means to the edge they are completely different cache keys, two completely separate objects, cached separately. Hold on to that one, it is about to pay off. But the cache key is also exactly where things go wrong. And here is the pattern to hold on to. Put too much into the key and it splinters. Put too little and it leaks. So, too much first if you fold something per person into the key, like a session cookie, that little per user token your browser carries, then every single user ends up with their own key, their own private copy. The shell splinters, nearly everything becomes a miss, and the CDN basically stops helping you. Now, Too little. The scarier one. If you cache something personal like a logged in page, but you don't separate it out by user, then the edge can hand you a private page to the next person who asks for that path. Same key, wrong person. So, a shared cache has to be really, really careful about what counts as the same request. Okay, second big question. The edge is holding a copy. So, what happens when the real thing back at the origin changes? Now, the edge is sitting on a stale, out of date version. How does it know when to stop trusting it? This is called cache freshness. And fair warning, it is genuinely one of the hardest problems in all of computing. There is a famous joke that the two hardest things in the computer science are cache invalidation and naming things. And we are quite literally able to do both. The simplest answer is just a timer. Remember HTTP headers from a few videos ago? Well, the origin can attach a header cache control that basically says keep this copy for let us say 10 minutes, and after 10 minutes the edge treats the copy as stale and quickly checks back home. Hey, has this changed? If not, great. It keeps it as a while longer. But here is the clever trick, and it wires straight back to the cache key. For things that almost never change, your logo, your compiled code, you do not try to update them in place. Instead, you stamp a little fingerprint of the file's content right into its name, something like main.a3f8b2.css, and you tell the edge, cache this one effectively forever, like a whole year. So, then how do you ever change it? You don't. You change the name, new contents, new fingerprint, main.9c2f1e, unto the edge, that is a brand new cache key. Your page's HTML, which itself is only cached for a short time, now points at the new name. So, browsers and edges naturally start asking for the new file, and the old copy quietly retires by itself. So the clever move is not some magic update everywhere button. It is to never need one. You just rename. And yes, there is a purge button if you truly must force it, but renaming is usually cleaner because a fresh name gets past both the CDN's cache and everyone's browser cache in one go. One distinction before we close, because it clears up a lot of confusion. You have actually met caching before. Your browser caches things too. But there is a huge difference. Your browser's cache is private on your laptop for you only. A CDN's cache is shared. One copy near a city, serving everybody there. And that is exactly the leak we just saw with the cache key. A private cache can safely hold your personal stuff. A shared one cannot, which gives us the one clean rule for what a CDN can and cannot cache. And forget static versus dynamic. That rule trips people up. The real question is shared versus personal. Is this the same for everyone? Your logo, an article, a product page that is shared. So cache it near everyone. Is it yours only? Your logged in dashboard, your shopping cart, anything you are saving or paying that has to go home to the origin. And the in between, even a busy news homepage can be cached for say 10 seconds. Because of those 10 seconds, everyone is getting the exact same thing. And honestly, this is the whole request path now. Think about everything we have built in this series. You type a URL, DNS turns it into an address, and for a CDN, the address of the nearest edge. Your request arrives there. If it is a cache hit, it ends right there at an edge, just a few milliseconds from you. It never has to make that long trip home at all. And only if it is a miss does it travel all the way back. First to the front door, the reverse proxy from last time, doing its load balancing and gateway jobs all in one box. Then to one of the stateless servers behind it, which finally talks to the database. That is the journey. You now understand from end to end what actually happens when you open a website. And there is one last thread to pull. The edge turns out to be such a good place to stand right next to everyone that people started running actual code out there, not just storing copies, but computing at the edge. That is called edge computing. And it's a whole story of its own. But for today, same middleman a copy near you, and the fastest request is the one that never had to travel far at all. See you in the next one.